This terrible tragedy, this senseless loss of life, could so easily have been avoided. Unfortunately, this train was not driven by a drunk driver, but by a dumb controller board that had no idea where the train was or how to stop it. This Arduino Mega can support up to 48 sensor inputs, so there's no reason why you can't make your Lego trains a bit more intelligent. Here's how. There are plenty of sensors available for your Arduino. Ultrasonic sensors, photoresistors, and infrared receivers. This one is an optical sensor. There are many different types, shapes, and sizes of these, but they all have one thing in common, which is the little disc on the front. That disc is a light-sensitive resistor. It puts out a varying signal depending on the light it receives. On this version, you can adjust the sensitivity by twiddling the screw on the resistor, so it will work well in both daylight and under your house lights. At the other end, we have 3 pins, one ground wire, one sensor wire, and one 5-volt power wire. That sensor wire goes to one of the Arduino's analog inputs. Plug any sensor into these pins, and you'll get a value between 0 and 1023, which we can use to trigger different events from the Arduino. For example, we can stop the train if the value gets too low. To fit this to our track, we simply place the sensor between the rails so that it's covered by a train. To hold it in place, we can make a simple frame out of Lego. Here are the basic pieces, including a trans red tile to show you the sensor's LED. Good work, mystery hands! And here's some code. Just like our previous video, we need to declare the motor pins to get the train running, and we've declared the input pin for the light sensor called LDR, for light dependent resistor. We've also got 2 more numbers called variables. LDR is the physical pin on the Arduino, LDR value is a reading we get from that pin, and we're going to use that value to make some decisions about the Arduino. Remember, it varies between 0 and 1023, so I've created another value called light sensitivity to compare LDR value with. We've also got a value called previous millis, and an interval of 5000 milliseconds, so 5 seconds. We'll cover those in a moment. In the setup section, we have some more familiar faces. This is where we declare our motor control pins, and this time we're going to fix the train's direction. It's only going to move forwards, not backwards. Instead, we're going to play with the train's speed later on using the ENA value. We also have something new. This serial command tells the Arduino to start reading inputs. Begin means, well, begin, and 9600 is the speed to read the inputs in bits per second. To give you some comparison, that's the speed of a modem in about 1988. And we can read that signal via the Arduino IDE's serial monitor. Down in the loop section, things look pretty complicated, so I'm going to jump around a bit. Try to keep up. First off, we make another new variable called LDRValNow. This is the current reading of the light sensor this millisecond, and we make that reading here using our analog read command. Then we ask a question. Is that reading bigger than our light sensitivity value that we declared earlier? Remember, light sensitivity of 500 is about halfway between the minimum and maximum values of the light sensors 0 and 1023. So if LDR val now is bigger, then the sensor must be blocked. So there must be a train on top of it. Brilliant. We know the train's arrived at this point. So we stop the train, right? Not just yet. If we stop the train here, it would never move again, because LDR value would always be greater than light sensitivity because of the massive train on top of the sensor. So we compare this current sensor reading to what it was the last time we checked, which is LDR value. If LDR value now is high, but it used to be low, then we can turn the train off by analog writing ENA to 0. But how do we know what the LDR value used to be? If we skip to the very bottom of the loop here, we save LDR value now as LDR value. That way, in the next millisecond of the loop, we know what the light value was the last time we checked. So let's go back into the loop. We stop the train, and the sensor reading is high and it used to be low. So the train's just arrived. Let's save that time using the millis command. Now millis is a built-in stopwatch for your Arduino. It starts counting milliseconds as soon as you turn the Arduino on. What we do here is tell the Arduino to save the current time as a value called previous millis. Now let's check this if statement. If the stopwatch minus the time the train arrived is greater than our interval of 5 seconds, then we power up the train and we give ENA a speed of 160. Obviously, if it's not more than 5 seconds, don't do anything, keep the train off. And of course, if nothing is happening at the sensor, just keep the train running. Let's run through this whole program again in plain English. Check the sensor. If the sensor is blocked, and it didn't used to be blocked, then stop the train and save the time. But if the sensor was blocked and it's been more than 5 seconds, start the train. And if the sensor's not blocked, keep the train running. Using this loop, the train will stop at our station for 5 seconds every time. And no one has to die. Hopefully. Now all we need to do is plug everything in and let it run. Now the train's already parked on the sensor, so we need to wait 5 seconds for the millis count to run out, and off she goes. Next time around, the train triggers the sensor, and the track powers down for 5 seconds again. You'll notice here that the train doesn't stop immediately. Quite simply, the weight of the train and the speed it's running at makes it roll some way past the sensor, so you'll have to play around with the position of your own sensors, and don't forget to modify the interval and ENA values in your own code to regulate the wait time and your train speed. Thanks for watching!